Record Elenda post YouTube. Okay, so today we are talking about organic chemistry 1. Welcome to our YouTube space, and we are doing organic chemistry 1. Organic chemistry 1 is topic 3 of book 3. Okay, so we are focusing on organic chemistry 1, and in organic chemistry 1 we focus on hydrocarbons. So the very first thing we are going to study under this topic is this. Hydrocarbons are compounds which are made up of carbon and hydrogen only. So as you can see, hydrocarbons. So the hydrocarbons, basically what you need to understand is very simple. As the name suggests, hydrocarbon. We have hydrogen and we have carbon. Okay? Yes, we have hydrogen and we have carbon. So in Form 3, we are only going to focus on organic compound that has carbon and hydrogen. In Form 4, we focus on something called alkanols and alkanoic acids. Okay? But in Form 3, we are going to focus on hydrocarbon. You only see carbon and you see hydrogen. So they are divided into groups. So there are 3 groups. So they are divided in groups. So these are the 3 groups. So the groups are alkanes. We have the alkanes, we have the alkenes, and we have the alkynes. So this one, the first one, you're able to see here, alkanes. So the alkanes, we are going to see that it has single carbon bond. The single carbon bond throughout. Then the alkenes, this one, the alkenes, you are going to see that we have at least one double bond. Sawa? We have at least one double bond. And the alkynes, which is the last one here, we are going to see that we have at least one triple bond. So this thing is divided into 3. So, and it is divided into 3. Here we are focusing on the number of bonds. So if there are single carbon bonds throughout, then that is an alkane. If by any chance at some point we have the double bond, that is what? Alkenes. And if by any chance we have the triple bond, we are going to say it is called the alkynes with the Y. So let's start with alkanes. So this topic is very important. Why is it important? It is important because in any chemistry exam, the ones you people have done and the ones you people are yet to do, all of them have organic chemistry in it. That question must be examined. And for the record, that was last year Kcse, that is Kcse 2023. It was examined. It was there in the exam. It was in chemistry paper 2. Actually, I have that paper here. Okay? So that's how important it is. So you need to know it. Okay? Not only it is examined in chemistry paper 2, but also in the practical and also in the chemistry paper 1. So that's how important it is. So let's focus on alkanes. So alkanes, what are alkanes? Alkanes are a group of hydrocarbons whose carbon atoms are linked by single covalent bonds. They are linked by single covalent bond. So the carbon atoms, they have the single covalent bonds through within them. So alkanes, they have single covalent bonds between them. So there is no double bond, there is no triple bond in alkanes. Okay? Yes. This point is very important. Hydrocarbons in which only single covalent bonds are present in the molecule are said to be saturated. Why are we saying that they are saturated? We are saying they are saturated because inakwanga imejaa, hakuna space kitu ingine inaweza kuwa. What do I mean by that? For example, you'll find an alkane like this one. Be very attentive. An alkane like this one. So this one is an alkane. This one is alkane. This one is an alkane. So this one is an example of an alkane. And this one will be propane because it has 3 carbon atoms. This one is propane. So this propane of ours, it is saturated. Why am I saying that it is saturated? Of course, there's no extra space where we can fit anything, because as you look at this carbon, because from book 2, you are able to learn that carbon is number 6 in the periodic table. So if it is number 6, its electron configuration is 2 to 4. So it means that it uses its 4 electrons to bond. So carbon can only bond 4 times. That's why the bonds here are 4. Around any carbon, you're going to see that we have 4 bonds. Because if you can count 1, 2, 3, 4. So carbon inajaa na 4. Ikifika 4 itakuwa imejaa. So because of that, carbon has already been filled and it is occupied. The hydrogen are occupying it around it. So there is no any other space for anything else. So if you have to put anything in here, be it chlorine or bromine or fluorine, what must happen is that you must displace the existing hydrogen. Okay, are you seeing that? So for anything to get into this alkane, you must displace the existing hydrogen. So that's why we are saying it is saturated. It is saturated inamaanisha yani tayari imejaa. Tukikuja kwa alkenes yenye kona double bond, utaona tunaweza fungua hiyo bond, hii bond nyingine tupatie kitu nyingine. Ukikuja kwa alkynes, that is triple bond, tunaweza fungua hizo bonds tupatie kitu nyingine. Hatutaharibu zile namba za hydrogen ziko. Lakini in alkenes, ndio to fix kitu lazima tuharibu the number of hydrogen that exist. So that's why it is a saturated hydrocarbon. And saturated hydrocarbons, they burn with a blue color. So saturated hydrocarbons, they burn with a blue color. Okay? Then unsaturated hydrocarbons, that one will assist us in chemistry paper 3. That is the practical. So the unsaturated one. So the unsaturated one is the double bond and the triple bond. That is alkenes and alkynes. They are going to burn with a yellow sooty flame. So they produce the yellow sooty flame. But the unsaturated, which is the alkane, they burn with the blue non-sooty flame. Okay? Yes. A good example of something from alkanes is the gas you use at home. Ukiangalia hiyo gas iko nyumbani, huwa ina burn ikiwa blue. Si mainly ile gas inatumika nyumbani, mainly inakuanga blue in color. That one is an alkane. Okay? Yes, hiyo inakuanga ni alkane. So it is from the class of alkane. Can be butane. Many of the alkanes are used as fuel. So siku nyingine ukijiuliza use of any alkane, anza na ile gas pale nyumbani. It is used as a fuel. So something like that. So for the sake of practical, inafaa tujue alkanes, they burn with a blue non-sooty flame, because unaonanga gas pale nyumbani haitachafua sufuria, haitakuwa imeacha moshi moshi. Lakini now the alkenes, the double bond, and the alkynes, the triple bond, huwa ni yellow na inaacha moshi. Ni kama ile utumie kuni kupika, the firewood. So firewood ukipika nayo sufuria utapata imechafuka huko nje, because hiyo flame inakuanga yellow na iko na soot. Okay? Aya, let's talk about sources of alkanes. Where do you get these alkanes? Okay? Yeah, this is a question that sometimes they examine in chemistry paper 1. So sometimes you might be asked. So sources of alkanes. So sources of alkanes occur naturally as natural gas, biogas, and in crude oil. So also you can just get the alkanes naturally. You can obtain them naturally in form of the natural gas, the biogas, and also in crude oil. Other than that, there is also a way we can separate them through fractional distillation. They can also be separated by fractional distillation. There's something that I want to talk about. Yes. I wanted to talk about cracking of alkanes. So we have said that the source for alkanes, you can obtain them in naturally from the natural gas from crude oil. Okay, so let's talk about cracking of alkanes. This is something that is very important. Okay, we are having this class simultaneously. So it is happening here where we are, and we are also sharing the same video on YouTube. Okay, yes, so if you have a question, you also ask. So my YouTube people, we are having a class also as well from this side. Cracking of alkanes. So, sometimes these alkanes, they can be very long, because it can be a long chain of carbon atoms. You can even have 10 carbon atoms when they are following each other. So you have carbon, 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 carbon. So it can be very long. They can even as big as maybe you can have even 30 carbon atoms following each other. So it means that this thing normally contains a lot of hydrogen and a lot of carbon. So when you have maybe when the carbons are maybe 10, when these carbons are maybe 10, and you want to make them to be a little bit smaller or shorter. So if you want them to be a little bit smaller or shorter, so what do? You crack them. Cracking them is you are making them to be short. So long chain alkanes are broken up through a process called cracking of alkanes. Okay? And in cracking of alkanes, so what do we basically do? So we heat them. So when you heat them, okay, there are two ways. There are two ways of cracking the alkanes. There are normally two methods. You can use the heat or you can use the catalyst. So what does that mean? There are two ways of cracking the alkanes. We have the thermal cracking. Thermal, as the name suggests, thermal is heat. And the other one is catalytic cracking. I think I've written it here. Yes, it is here in the notes. As you can see there are two ways of cracking of alkanes. Okay, this thing has always been examined in a certain mock. It was examined that at least two ways of cracking alkanes. So the two ways are always the thermal cracking and the catalytic cracking. So and the catalytic. So there are two ways of cracking these. Cracking is basically these long chain alkanes, you are making them to be short. So you can use heat. Thermal, now you are going to use heat to make them to be shorter. Then in catalytic cracking, you are going to use what? A catalyst to make them to be shorter. That's all that you need to know. Nothing else other than that. Let's go to nomenclature. Nomenclature is now the naming of alkanes. Nomenclature is just naming. Kama hiyo kizungu inaweza kuwa inakupita. Nomenclature ni naming. Sawa sawa? Nomenclature is just naming. How do you name them? Naming of alkanes. So naming of alkanes. How do you there is a spelling mistake. There was apostrophe there. So how do you name alkanes? Okay, so how do you name alkanes? So before we know how to name these alkanes, the first thing that you need to know is this. So maybe let me see if it's written here. No, I've not captured it. Oh, but it is here. Oh, we are going to use this one, the lower one. But let me say something before that. So the very first thing is that in naming of alkanes, the most important thing is going to be the number of carbon atoms. Use the number of carbon atoms to know the name of that alkane. Okay, so for example, if you have one carbon atom, that is methane. If you have two carbon atoms, that is ethane. If you have three, then that is propane, in that order. So, and of course, with the help of mathematics, you have done some of these things in polygons. So you're only going to use the prefix. So you're going to use the prefix even in maths when you're doing the polygons, octagon, pentagon. So you're only going to use that and fix them. So those prefixes, and you're going to put them here. So here is a table that you need to capture. Yes, you need to have something like this. Yeah, you need to have something like this. So here we have the number of carbon atoms. Then here is going to be the name. Then here we have the molecular formula. Then we have the open structure formula. These ones are just enough. Leave these two. So if you are writing it, just have 1, 2, 3, 4. Have the 4 columns. The skeletal formula is very relevant. They don't use it to examine. And the condensed structural formula, it's useful, but having this molecular formula at the moment is just okay. So this one is useful, but let's just have the 3 so that you don't have many things. So yeah, so let's use this one. So when you have one carbon atom, The name is methane. And how do we draw it? So the drawing is the structural formula. The drawing is the structural formula. So we only have one carbon, and remember we have said that carbon will bond 4 times because it uses its 4 electrons to bond completely. So that's why we have 4 bonds. These are not dashes or hyphen or just straight lines. They are bonds. Okay, so carbon, when we only have one carbon, it is going to bond 4 times. So the hydrogen, the number of hydrogens surrounding it will be 4. So that is CH4. Let's go to number 2. Number 2 is called ethane. So you need to master. Number 2 is called ethane. So ethane, if you can draw it, so we have C and another C. Then you now ensure that you fill the hydrogen around this carbon in a manner that each carbon has a maximum of 4. So for example, here, this is our single carbon. So if you count 1, 2, 3, 4, you're able to see that there are 4. The same to this one as well, this C. So we have 1, 2, 3, 4. So they share this one. So this one, you count it on this other side, you also count it on this other side. So as you can see, they have 4 at any given point. So if you now count it so that you can write the molecular formula, 1, 2, they are C, the carbon atoms are 2. Then let's count the hydrogen atoms, 1, 2, 3, 4, 5, 6. So that is why it said 6. So this column is meant for the molecular formula. So it continues. The format continues till we reach number 10. The format continues till we reach number 10. And I think that is something that all of us can basically understand. So I'm only going to show now the names, but the drawing you can basically understand, because for each carbon, you ensure that if you count those dashes, we can put in quotes, those hyphen in quotes, yet they are called the bonds. If you count them at any given instance, each carbon has 4. So if you can meet that at any given point, then you are okay. So the third one is always called the propane. So this is how its diagram is going to be. It's called the structural formula. 1, 2, 3. Then you now put the hydrogen around it. So they're going to be 8. Number 4 is called the butane. The most important thing is their naming, because drawing, all of us can basically comprehend this. So we have 1, 2, 3, 4. So these are now 4 carbon atoms. Then now you add hydrogen around them. So for example, here, this carbon, 1, 2, 3, 4. You see, at any given point you must have 4. This carbon here, 1, 2, 3, 4. The same. They always share this one. The one in the middle, they will always share it. So they will always share it. So if you count all these carbon atoms, there are 4. If you count all these hydrogen atoms, there are 10. So number 4 is butane. This is its molecular formula. This is the structural formula. Let's go to number 5. Pentane. Pentagon. Pentane. Pentane has 5. So if this one is going to be its structural formula, and this one is the molecular formula. That's its molecular formula. Number 6 is called the hexane. This one is the molecular formula for hexane, and this one is the structural formula for hexane. Number 7 is called the heptane. This is the molecular formula for heptane, and this is the structural formula for heptane. Number 8, we call it octane. Okay, octagon. Octopizzo number 9. I believe you have heard of something like that. So oct. Octane. Octane now is 8. So octane is now 8. So, and this is its molecular formula. And this is how you write draw its structural formula. Then let's go to number 9. Number 9 is always called nonane. Inakumbusha unone kidogo. So nonane, and this is its molecular formula. And this is the structural formula. And lastly, number 10 is called decane. So you need to master them. Decane, this is how its molecular formula is written, and this is the structural formula. If you count all the carbon atoms, you'll find that there are 10. Then you now ensure that the concept of four bonds around carbon is met. So ensure that merit is met throughout. So there's always the formula, the general formula for, this is the general formula for alkanes. So this is the general formula for alkanes. So the general formula for alkanes is CnH2n plus 2. So for example, let's say we are focusing on number 7. Let's say we want the molecular formula for number 7. Okay, for instance. So that means that we have 7 carbon atoms. Okay, it means that we have 7 carbon atoms. So if you are going to have 7 carbon atoms, so that will be C7, then H. So the H, that is the hydrogen, it is going to be 2 multiplied by N, where N is the number of carbon atoms. So it is going to be 2 multiplied by 7. We are going to find that it is 14. Then you add a 2 to it plus 2. Then you add 2 to it. So our final answer is going to be C7, H, that is H16. And clearly, this C7, H16 was the same thing that was in this table. So if we get back to the table, basically we'll see the same thing. You see? Yes. So basically you get the same thing. So that is the shortcut, or rather the formula of obtaining their formulas. So C7, H16. So I find it to be, I feel drawing it is much easier than cramming the formula, the general formula, because you just draw them and ensure that all the hydrogen are next to the carbon. So I feel that is it's always very easy to obtain their molecular formula while you draw. I believe that's my biased opinion. But if you find the formula to be very okay with you, then you can master and use the formula. But I normally feel you try to draw them, then you count is the easiest way to get the formula. Okay, we want to talk about, we have not talked about the naming. Okay, were there the rules that were written here? Let me see if there are some rules that I was able to write here. No, I did not write the rules. But they are here. They are here. So let's talk about isomerism first. Then we'll now go to remember our broad topic was called nomenclature, or rather naming of alkanes. And as you can witness, I've not named any alkanes so far. Rather, what I've done, I've only mentioned their general names from number 1 to 10. That is what we have done so far. But let's talk about something called isomerism in alkanes. Then after that, we now see our first example on how to name them. So isomerism in alkanes. So in exam, the question that you expect is, what are isomers? Trust me, a question like that, you will do it in your chemistry exam at some point. Okay? Before you do your Kcse, a question like this, you must meet it somewhere. It might eventually be in your Kcse as well. So you can be asked, what are isomers? Isomers is almost close, the concept behind isotopes. So the concept behind isotopes is also the concept closed in the isomers. So isomers are compounds that have the same molecular formula but different structural formula. So if you are asked in an exam, what are isomers? Are compounds that have same molecular formula but different structural formula. Okay, I'll explain that perfectly. But at the moment, let's just know it that way. But I'll draw to show the difference. So isomerism, we can basically, I think we'll do an example of it below down here. So at the moment, just know that what is an isomer? An isomer are basically, isomers are compounds that have same molecular formula but different structural formula. So molecular formula ni tulikuwa tunaandika hivi easy kama hii C7H6, lakini structural formula ni kuzichora ile uko unaona C hyphen hizo bonds. So hizo ni structural formula. So we'll basically explain how that one happens. So we want to talk about the alkyl group. We want to talk about the alkyl group. So we want to talk about the alkyl group. So write alkyl group, then underline alkyl this. Write this alkyl group, then underline alkyl group, then underline. Then after writing alkyl group, then you have underlined. Then what you need to say is this: if any hydrogen, below it write this, if any hydrogen atom attached to an alkane chain is removed, an alkyl group is formed. So how do you form an alkyl group? By removing one hydrogen from an alkane. if any hydrogen atom, so our subtopic is alkyl group, if any hydrogen atom attached to an alkane chain is removed, an alkyl group is formed. Yes. So if you remove one hydrogen atom from alkane, from any given alkane, you get what is called alkyl group. For example, here's the example. So our number one alkane is methane. And how do you write methane? CH4. So if you remove one hydrogen from it, we are going to be what are you going to see? You are going to have CH3, because we have removed one hydrogen from this, so CH4. So what you remain with is CH3. Okay, so alkane yenye hydrogen moja imepunguzwa inaitwa alkyl. So jina yake haitakuwa methane, lakini unaitengeneza, unatumia tu the prefix, lakini now the suffix hapa itakuwa like hiyo alkyl, hiyo kyl. So methyl. So methyl is CH3. Okay, the second one is ethane. Ethane, now this is the condensed molecular formula. This is now the condensed molecular formula. Okay, but regardless, this is ethane. Okay, this is ethane. So if this is ethane, as you can see, we have 6 of hydrogen atoms. We have 6 of hydrogen atoms, because 3 plus 3, that's 6. Then we are going to remove 1. So it's now we're going to call it ethyl. So it's going to be CH3, CH2, because it was CH3, but now we have CH3 and CH2. So they are now 5 if you add them. So that is that. So the most common alkyl group are just the first two, methyl and ethyl. Okay? Yes, methyl and ethyl. But we can also have the propyl. It means that from propane, we remove one, we have the propyl, butyl from butane, and so on and so forth. So that is not really important. So what is now important are now the rules. Good. So let's write this. Rules for naming of branch alkanes. Good. So now we are in naming. So we want to see, how do you name them? How do you name them? Rules for naming of the branch alkanes. So what are the rules? We want to know how you can name this thing. What are the rules? So the very first important rule, which is our number one rule, identify the longest continuous carbon chain to determine the number of the parent alkane. Identify the longest continuous carbon chain to determine the name of the parent alkane. So always you need to identify the longest continuous carbon chain any given time, and that continuous is very important. Lazima hizi carbon atoms zinafuatana. So these carbon atoms, they should be following each other. So identify the longest continuous carbon chain. So identify the longest continuous carbon chain. So that is the first rule. And you want to see an example on how to apply that rule. So here, yes, so we have something like this. So when you have something like this, we want to try and identify how we're going to have our longest continuous carbon chain. How are we going to have our longest continuous carbon chain? So you try and count, and you follow any route. It doesn't mean that when it is in a straight line, that is the longest route. Okay? It only happens that the example, my first example I want to use, it obeys that logic where whatever is going to be on the straight line, that is horizontally, is going to be our answer. But you must always look for it. So let's try. Remember, it is longest continuous. They must be following each other. So there is this option. We have this carbon, we have another carbon, we have another carbon, and we have another carbon. All of them are following each other. So I can say that this is one of the continuous chain. I've not said it is the longest yet, but I'm saying that we can have that. Okay, let's also follow another route. Remember, they must be following each other. Okay, what if, let me use the green ink now. So let me follow this other one. These carbon atoms, you follow the carbon, not hydrogen. So what if we go this route, then we have that. So we can have that. So those carbon atoms, they are also following each other. Then lastly, let's use a blue ink now. So I can also start from the other end, the other side. That is from our right hand side. So can as well now that way I can go up to that point, then I can basically join that. So these are now the three combination that I have. These are the three combination that I have. So from these three, let's start with the red one. So how many carbon atoms do I have? 1, 2, 3, 4. So while using the red one, I have 4 continuous. The keyword is continuous. They are following each other. They should be following each other. That is the keyword. Okay. Let me check on the green one. 1, 2, 3. We have 3 following the route for the green one. And lastly, the blue one, the dotted blue one, we have 1, 2, 3, 4. So the red and the blue one, they have the same number of carbon atoms. So it means that you can use any of the two. So it means that the route that you can use to name this thing is either the blue one or the red one. We cannot use the green one because the green one is giving us less continuous carbon atoms. It is 3 versus 4. 4 of course is more than 3. So that is how you come to an agreement. So you can use either. So you're not going to use the green one. So let's rub it. So now we can use the red or we can use the blue one. But in any given point, if one of the routes is straight, then using the one that is straight is much more easier. But you're going to get the same result regardless, even if I was to use the blue one. So now we are going to have the red one. So anything that is now outside the one that you have considered to be the longest continuous chain, it happens to be now a branch. So anything that is outside, whatever you have picked to be your longest continuous carbon chain, we are now going to call it what? We are now going to call it a branch. So we have only a single branch. And our branch is CH3. And remember we said CH4 is methane. And we said from methane, if you remove one hydrogen, you are going to have the methyl. So what is below this one is now the methyl. So now after knowing the number of continuous carbon chain, then now we can give it a parent name. So 4. So what is the name we give to 4 continuous carbon atoms? So number 4 we call butane. So this thing is going to be called butane. That is now the parent name. It doesn't end at that point because there is one branch. There's a single branch. So its entire name cannot be butane. That will be wrong. Because there's something outside the butane. So the parent name is butane. Then now we are also going to name the branch. We are going to name the branch. So the branch is now basically the methyl. So after that we now go to another rule. Okay. So another rule after that, because in the first rule my interest was just identifying the parent name. So it was basically to identify the parent name. And I've shown you how to identify the parent name. Okay, the second rule is now number the longest chain from the end of the chain that is near the branching. Number the longest chain from the end of the chain that is near the branching. What do you mean by that? So I want to also explain that. I also want to explain that second rule. Number the longest chain from the end of the chain that is near the branching. Okay, this is what we mean by that concept. So this thing, you can count it from left to right or from right to left. The only thing that you consider is that let your branch have the lowest number as possible. Because we want our branch to have the lowest number as possible. Okay, so for example in